Here's your host, Jim Flyzik.
Good afternoon and welcome to this month's show. I'm Jim Flyzik, and during today's show we will discuss how the explosion of big data is being addressed in government programs. With me today on the show are Zach Goldstein, the Chief Information Officer and Director for High Performance Computing at NOAA, Robin Thottungal, the Chief Data Scientist at EPA, Frank Konieczny, the Chief Technology Officer at the U.S. Air Force, Chris Steele, the Chief Solutions Architect at Software AG Government Solutions, and Alan Ford, the Director, Teradata Government Systems, Teradata Corporation. Let's get into the discussion. Let's start with Zach over at NOAA. Zach, tell us a little bit about some of the where you're making progress with big data initiatives, where you see progress being made as you work these programs through.
Most progress we're making is in our big data project.
Okay.
Last time we talked, we had just set up our CRADAs, our cooperative research agreements, research and development agreements with some partners. The partners we have, to remind folks who may not have been following in the news, Amazon Web Services, Google, IBM, Microsoft, and the Open Commons Consortium, which is the largest cloud consortium in the academic world. It's led by the University of Chicago. These are the 5 largest cloud providers in the world.
Sure.
And the idea of this project, as we've discussed before, has always been that we need to change the business model from where we just store a lot of data, invest in the infrastructure to serve it up, and never quite catch up with the demand.
Right.
And our limitations and our ability to make those investments quick enough, and it ends up being a governor on 2 things. One, it takes resources away from our ability to invest in higher priority missions like protecting life and property, and it also doesn't stimulate the growth of the American economy. So the Big Data Project turns this on its head. We've made enormous progress since we last spoke.
Terrific.
We're serving up data to those 5 cloud providers. They're experimenting with whether they can make it a go, what types of data sell, and what types of data are interesting to other customers who want to put their computing requirements next to the data so that they can produce value-added products. Some more progress about that I'll discuss a little bit later in your show. And NOAA is learning how to deliver the data in the most efficient way to these providers, because their research is on the business model. Our research is on how do we be most efficient architecturally and process-wise to get the data to them, so that when our cost becomes part of their price, which is the way the model is supposed to work, we don't kill the goose that laid the golden egg. With our own things. So we have that. There's some other things going on as well. I'll just briefly allude to them. We have a NOAA One-Stop project, which is designed to create a single user interface to all of our archive data, focusing on the quality of metadata and discovery. We have a NOAA Data Citation project, where we assign uniquely worldwide identifiers to every data set that NOAA has for citation purposes and to promote scientific research. We have the N-Wave network, which I've talked about before, I believe.
Yeah, I'm going to ask you about specific programs next, too.
That we use to move around data. I can talk more about that later. And big data in NOAA is about observations and modeling and simulation. Everything we do starts with an observation, and that's about to change dramatically in terms of the volume. When we launch the GOES-R satellite in later this year, it's now scheduled currently for October 2016, there will be a 7 times increase in the amount of satellite data that we're ingesting. And for that, we're making improvements to N-Wave, but we're also, very importantly, making improvements to the communications networks of the National Weather Service to move that data around.
Cloud providers and things like that, too. You know, it's interesting because back in the days of doing the Reinventing Government, we actually did some studies, and we identified just huge volumes of data that was being collected by various agencies that was basically going into bit buckets because, number one, they couldn't process it all, and number 2, they only needed small amounts of the total volumes to do what they were doing. But all that other data that was just like going into a bit bucket somewhere was tremendously valuable to other agencies or to industry or whatever. And it sounds to me like that's some of the things you're capitalizing on now. Frank Konieczny, how about that Air Force? Talk a little bit about some of the progress you're making with big data programs.
Well, first of all, the scope of big data in the Air Force is kind of large because we talk about big data in terms of emails, we talk about big data in terms of network transaction flows that we have. billions of those. We talk about in terms of documents. We have 4 billion documents plus 4 billion documents out there that we have to track and keep track of. We also have simulations and modeling data at the same time. And that's not including even the ISR videos that we gather petabytes of data per day. So big data for us is all the time big data for us. Now what we've done is we've formed now a Air Force data panel to actually look at data across the Air Force as an enterprise, because we want to say data is really an asset that we have to utilize. Sure. With the intent of eventually controlling the data, making standard policy for that data and how we're going to utilize it, as well as probably talking about setting up a chief data officer to actually manage it all.
That trend's out there. I was going to ask you about that when you brought it up. There are a number of agencies now creating chief data officers.
Yeah, because we decided we have to. The main thing is that data is really a real asset for us, and we have to start treating it as an asset as opposed to something else. We also have talked about having developed an information management application which will actually control all the data within the Air Force in terms of tagging and access control and everything else associated with it, as well as we're doing predictive analysis and classification analysis on the data as well. Because you can imagine the 4 billion documents that we have to determine the disposition codes in all those documents. Right.
Yeah, I know the business analytics associated with big data is a big deal too. I mean, there's all kinds of tools out there coming out now, because when we have that massive amounts of data, to be able to sort through it and actually find out what it is that you actually need is interesting. Chris Steele over at Software AG Government Solutions. How are you positioning in this world of big data, and how are you supporting your customer base in the federal government?
Good afternoon, Jim. Thanks. So we've been seeing a lot of interest picking up in big data over the last couple of years. Even since the last time we were on here talking about big data, we've seen just an increase, not in just the breadth of the interest across the different agencies, but also in how they're using big data within the agencies. So I was at an intelligence community show yesterday, and talking to the different vendors that were there, I would say probably 60 to 70% were in the big data space. Two of the vendors I talked to, their sole customers were government agencies. So I think that's a big change since the last time. And not just if we look at static big data, the Hadoop and vendors around that, we're also seeing a lot of interest generated in streaming analytics, in-memory databases, a lot of these different technologies. So I think we're sort of past that first wave of interest, and now, as Frank was saying, agencies are really looking into how we can take all of that big data and really turn it into, mission-critical information.
Yeah, I'm seeing some interesting things too that don't come to mind with traditional big data collection. I'm seeing, like body-worn cameras and streaming video and having analytics that can, look through that video and stream that. And a lot of efforts on social engineering sites to be able to data mine those and collect lots of information to look for patterns and things that shouldn't be there and things like that. So it just continues to evolve in all kinds of directions. Robin Thottungal over at EPA. Tell us a little bit about some of the progress EPA is making with big data programs.
So first of all, thanks for having me on the show, and good afternoon to the panelists and to Tim. So I think I would like to take a different spin on the question. Okay. And from an EPA perspective, when I think about EPA, our mission is to protect the environment and the human health. Ultimately, that's our goal. Sure. So with that in mind, I think I want to share is a couple of scenarios that is been facing everybody on the planet. A couple of them are, one is called alga blooms, and another one is a problem called Gulf of Mexico dead zones. And let me go a bit deep into what that means. So alga blooms is a phenomenon that happens in usually Great Lakes or some of the water bodies where you have immense amount of cyanobacteria growing. And the reason behind that is due to the runoff of chemicals or fertilizers into the system. And the same thing is in Gulf of Mexico, it's called dead zone. And the alarming problem about this dead zone is it's the size of Connecticut. It has gone to the size of Connecticut, and it is a region where there is no marine life because of the lack of oxygen. And it doesn't happen throughout the year, but it happens through a part of the year. Now, the reason I am bringing this up is if you think about this problem, this is a result of the runoff coming out of the Mississippi River to the Gulf of Mexico, or in case of Lake Erie and other water bodies, it's because of the perfect condition it creates because of the runoff coming to the streams. Okay. And this runoff can be a result of a couple of issues. One is the factories discharging certain type of fertilizers, certain type of chemicals into the system. Usually it's some kind of a phosphorus or nitrogen, which we can monitor because we have regulations that will help us say that, what is the type of discharge that you are having into the water system. Now, the bigger challenge that we have here is non-point sources, which is coming off fertilizer plant, which is coming off not factories like cattle feeds or farmlands. And it is very difficult to calculate that value because we don't have a mechanism to ask, okay, how much fertilizer have you put into your system and how much it is running off. Now, from a big data standpoint,
I'm looking for the big data connection
Yes, the connection is coming, don't worry. So if you think about this problem, you have remote sensing that will help us satellite images. That is terabytes of data set. And what is currently happening is, Zach from NOAA can speak about this too, right? We have terabytes of data that is coming up. And the question is, how can we use machine learning and predictions on these large volume data set to see if we can calculate and estimate the non-point estimations.
Very interesting.
So this is a very interesting classic case where we are bringing in big data to directly support the mission of an agency. And to go to the big data example, if you look at a Landsat images, and if you have, I think, 20 different spectrums, it's close to 125 GB of data set per day if you scan the complete US, right?
That's cool. You're exactly right. It's terrible. There's another one. I said just a few minutes ago, I hear all these other interesting ways to use it. There's another example that doesn't come to mind. Thank you, Robin. Alan Ford at Teradata. Well, I think at Teradata, Teradata sounds like a lot of data, that's the name of the company. Tell us a little bit about the progress you're seeing with big data and how you're supporting your customer base as you move forward with your programs.
So, Jim, we've been hard at work at Teradata generating big data use cases we think would be of interest to our federal customers and prospects. And as an example of one that's created quite a bit of interest, we have been using social media analytics to identify Islamic State members and supporters. Their use of social media is very sophisticated. It's an effective tool for terrorist recruitment. And it's also a big data problem given that the potential set of social media accounts related to one individual can get overwhelming quite quickly. For example, just 3 layers in to the friends and followers of a single individual, you can get over 1 million users very quickly. It's too much to analyze manually. So we've developed multi-genre big data analytics to identify tweets and accounts of interest using Twitter data. We then used linguistic analytics to refine lists of suspects based on expression patterns in tweets and further elicited intent from them. And this allowed us to generate a small set of accounts that we could then map and identify the most influential suspects and their sphere of influence. Besides the obvious benefit to identifying bad actors in the terrorist space, this work is easily translatable to other social networking problems such as drug and human trafficking, and even generating applications of interest to Border Patrol. So.
Yeah, I know there's been a lot of talk on the Hill too about abuse of prescription drugs and trying to get a handle on that, and trying to use big data to try to figure out what's where the abuses are occurring and so forth and so forth. So all kinds of things going on there. Very good. Let's talk. Frank, if I ask you to pick a specific program at the Air Force where you think big data is going to make a big difference, what would you? What would come to mind?
Well, there's one that's interesting that we started to do, which is called fuel usage.
Fuel usage.
Yes.
Okay.
We're finding that as we look at various exercises and the way that pilots actually fly their aircraft, there's a difference in the amount of fuel that they actually use. And a lot that goes back to the training that they've already have established, or the bad training they've established according to what they've done. And we find that, for instance, a particular squadron was actually using more fuel than anyone else, and we finally related it back to the training that they had, that their maneuvers that they were doing actually were not more effective, but they're actually using more fuel when they were doing the maneuvers. And so it went back to training to schoolhouse and figure out what you need to tell everybody else going forward to actually save fuel, because we spend a lot of money on fuel.
I bet. I bet. Interesting. Very interesting. Another interesting case there. Robin, what do you think? If I ask you, you mentioned one already, but if I said to you, give me a program that comes to mind at EPA where you think big data is going to really make a difference, other than the water purification you talked about, is there something else that would come to mind?
Yes, definitely. So if you look at EPA, we have enforcement as one of our missions too. Mm-hmm. So in that aspect, what we are seeing is it's not the data set that we have within the organization. When we bring in data from other agencies, that is giving us more insights into identifying the bad actors. So one of the classic examples is we are getting data from Coast Guard, data from Department of State, or we are getting data set from Homeland Security, we are getting data set from NOAA, we are getting data set from USDA. So what that means is we can bring that data into our own analytical platform and bring that data, match that data set with the other programs. In case of the Coast Guard, we were able to look at how the ships are, the behavior of the ship, and see that if they are actually compliant to our regulations. If not, can we do some kind of analysis to predict them? So enforcement is an area where I'm seeing the benefit of big data and analytics, and it's not because of the way we are using the data within the organization. It's because of the interagency and intra-agency collaborations that we are establishing. Yeah. And another aspect is bringing that into the cloud, which will help us more collaboration across the agency.
Yeah, it's a collaboration and sharing of information, a big deal. Zach, if I ask you to throw a specific program out there on the table that you think big data is making a big difference at NOAA, what comes to mind?
What comes to mind is our big data project.
Okay, the one that you talked about?
The one I was talking about earlier. In terms of the impact, it's already made. So far, we've taken, the most significant thing I think we've done is we've transferred to 4 of our 5 collaborators the entirety of our Doppler Weather Radar Level 2, NEXRAD L2 data set, 270 terabytes, 180 million files. And they've got it, and because they're working independently, I'm going to just take a snapshot at where we stand right now, because we've already seen one really important effect. Mm-hmm. So Amazon Web Services is currently serving not just the archive, the 25 years of archive data, but they're also serving NEXRAD real-time. And what that's enabled them to do is meet the needs of a very key customer who was part of the thinking when we first put this together, and that's the Climate Corporation.
Okay.
The Climate Corporation has, in their partnership with Amazon, been able to reduce their time to market for their data products by 2 to 3 weeks.
Okay.
And that's a significant advantage in business, right? They're also able to use the Amazon platform next to the data to improve their analytical methods and get increased accuracy in their products. So we're starting to see the beginning of the business case being developed by the partners that we envisioned. The impact on NOAA is also striking in just this very first instance.
Right.
What we've seen is a 60% reduction in the demand for that very same NEXRAD archive data in NOAA's archive. Oh, wow. And what that does
frees up time to do other things.
Frees up time to do other things. It frees up cycles to do other things. It allows our scientists to be focusing on what's the next basic science we can do with this data and the data science we can do on this data, rather than spending a whole bunch of time just serving it up. So that's impressive. A couple other comments I just want to make. We were talking about the moving around data.
Right.
Last time I was on your program, we were discussing NWAVE, which is becoming NOAA's network for moving around these massive volumes of data. By the way, unlike other places, we put all of our massive volumes of data through trusted internet connections, which requires a lot of bandwidth there. But we're moving from 10 gigabytes nationwide to 100 gigabytes nationwide. That's happening. And one quick comment about my colleague from EPA, because I know people from NOAA will be listening. We do the harmful algal bloom forecast, and we do harmful algal bloom warnings using satellite data in the same big data sets that you're describing. What I heard that was unique and absolutely exciting is taking that with all the other data you have and seeing, okay, it's great that NOAA's telling you when it's going to happen. Who's going to do something about it? And kudos to big data on the causal analysis and maybe some regulatory solutions. Well, interesting.
Glad I got you guys together in the show to talk about this stuff. It works out. I want to hear from our industry guest on this too. And remember when Amazon used to sell books? I want to hear from our industry guest, but we need to take a short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio 1500 AM. I'm Jim Flyzik here with Zach Goldstein from NOAA, Robin Thottungal from EPA, Frank Konieczny from U.S. Air Force, Chris Steele, Software AG Government Solutions, and Alan Ford from Teradata Corporation. We're talking big data. We were talking about specific programs that we think may make a difference. And let's talk to Alan here. Alan Ford over at Teradata. What comes to mind if I ask you, give me a specific program that you think is going to make a big difference by utilizing big data?
Well, I'll join Frank and cite an example that we're doing some work at the Air Force, data-driven vehicle management at the 441st Vehicle Support Chain Operations Squadron. They've got the fourth largest federal vehicle fleet in existence, more than 78,000 assets worldwide, valued at more than $7 billion. And it's a very diverse fleet, more than 500 distinct vehicle types, sedans, snowplows, fire trucks, cargo loaders, anything that the Air Force needs to conduct operations. So this system takes direct data feeds from vehicle onboard sensors, maintenance logs, supply and logistics system data, and enables drill-down reporting and analytics functionality at either the command, the fleet, down to the individual asset level. Wow. And so the Air Force has saved over $300 million in the past 3 years by tracking their fleet with this system. It allows for more accurate budgeting, better predictions of end-of-life status for these assets, and big data is even enabling what-if scenarios for simulating the impact of funding adjustments, for example.
Terrific. Fantastic. We were talking, before we start recording, we were talking about the amount of computers that are in cars today and the things that are going to be happening in cars down the road. And I mentioned here at a car company predicting that the value of the computers in the car in the future will exceed the value of the car itself. Chris Steele, Software AG, when I ask you for a specific program that you think is going to really make a big difference utilizing big data, something come to mind?
Yeah, actually, I'll go ahead and build on Alan's and say, when you start to think about all of those different vehicles, we've been talking to several of our customers about condition-based maintenance. So being able to collect all the information from all of those vehicles to understand when and how to best provide maintenance for those. So we have an example with one customer where they've got large million-dollar engines, and through predictive maintenance algorithms, we've been able to save them literally tens of millions of dollars a year by proactively understanding when to go in, send a technician in before there's actually a failure within the engine itself. Because at that point, then you start replacing expensive parts. Sure. You have to put somebody on site versus proactive maintenance, where you can go out and you can fix the problem, replace the oil, things like that. Absolutely. Before an issue happens. And then in terms of really big data, if you look at the next generation of engines that are coming out from Boeing, they've got literally thousands of sensors on them. And so they approached us with the problem that we've got so much data coming from each engine, we don't know how to manage it all. Yeah, right. And so now we need to examine how are we going to take all of that sensor data and turn that into predictive maintenance.
Mm-hmm. Interesting, very interesting. Let's talk about some lessons learned. Frank, what are some of the lessons you're learning as you work these big data programs? What are some of the things that you'd pass on to colleagues working the same programs as maybe things you've learned along the way?
Well, we have so much data. The question always is what do you want to get out of the data? What is the main objective? Because people just say, oh, let's analyze data and figure out what's different. And we're like, well, that's really great, but what do you really want to get out of the data? And a lot of times the problem we have is that you have to have a good baseline. I mean, we've done behavioral analysis for insider threats and everything else, and if you don't use a correct baseline, you'll never see any deviations from it. Right. Or if the bad guy's already in there, he may be part of the baseline, and you will never ever pick him out. So,
good point.
And the other part of it is also you got to make sure that the data is valid and the data is trustworthy and it's relevant to the time that you're in, because a lot of times you think that data is good forever, right, and it's not. And the issue that we have is we have so much data, we almost want to say, it should be a use-by date on the data so that we can figure out when you should dump the data.
Yeah, kind of like buying a carton of eggs used by a certain date.
Right, because otherwise it becomes stale, and you may make the wrong decisions on that stale data then.
Yeah, good point. So, Zach, what do you think? What are some lessons that you're learning along the way here?
So, back to the Big Data Project, things we've learned, it's not true that if you build it, they will come.
Okay.
you've got to do two things to make this work. One is make sure that the data is high quality, that the metadata is there. I think we all knew that.
Right.
The other thing we're learning is that we have to prime the pump in this exercise. The folks that we're dealing with are really smart folks. They understand the technology, they understand computing, they understand that marketplace. There are other people who are going to be providing value-added services on government data, and they understand technology somewhat, but they're also not the people that we're going to be dealing with directly, because then we just create a bunch of functional stovepipes.
Right.
So we have to prime the pump. We've got to take the time, and this is what we're doing, take the time to introduce folks to the possibilities of what you can do with the government data and get the conversation going. Mm-hmm. So we have a new program manager that we've assigned to this project, and one of the reasons she's not here with us today talking about this is because she's out priming the pump.
Okay.
She's discussing at a data conference what you can do in terms of value-added services, how you might be able to get to them. So that was an important lesson.
Sure.
I think we'll be able to remove ourselves from that so that the right data will be there. And what's great about this is we're not just putting a bunch of data out there to see who's interested.
Right.
What we're learning is that if you take the time to get the conversation going, you can get the right data out there that will actually be of market value.
Right.
And so we're learning, as I indicated from the example a little bit earlier in the show, that they actually can have market value from the data.
Absolutely.
It can free up cycles for us. We can focus on building businesses, creating jobs. This allows us to easily comply with open data policy. The movement doesn't have to be at a cost to the government. It removes the bottleneck of government budgets as a pacing function for ability to get data out and stimulate the economy. And shifts our concentration from just moving data to actually analyzing it and getting more value out of it for the government as well.
Yeah. So I think what my takeaway from what you just said there is you got to create the understanding of the possibilities of what can be done with this data, other than collecting the data because there's a lot of data that's collected. Robin, what are some of the lessons you're learning along the way here?
So I think I want to give a bit perspective on when I started an EPA in September of 2015, and one of the things that we have done differently there is, instead of going with the traditional waterfall approach of developing a project, I have been embracing the concept of lean startup within the organization, which is basically, for the audience who might be thinking, what is lean startup? Because people confuse this with the Six Sigma lean from the Japan. This is the lean startup approach that is used by the companies in Silicon Valley or any startup to build products on a faster time frame. Now, the reason I am bringing this up is, if you think about this problem, I have 3 problems that I need to face when I'm building a portfolio. One is the people, another one is the technology, and the third one is the finances or the budget that everybody is aware of. So the idea of lean startup is you are building, measuring, and learning from it on a minimum viable product. So in that aspect, what we have done there is we don't need to wait for the government or the Congress to give me $1 million to start a project, right? I am going to get a very small amount of money and have conversation across the agencies and start building prototypes that might serve the 10% of the need that they have. It may not give the 100% capability they are looking for, but it gets a 10%.
You're proving the concept.
Yes. So that way, what happens is, what we are seeing because of this approach is, we are seeing more and more programs across the agency coming to my office and telling us, we have money, we have a problem, can we build a prototype to make sure that we are going in the right direction?
Sure.
Then from a people standpoint, what we have done is, and I should not be taking the credit for this one, because even before I joined the EPA, my staff, there were a couple of visionaries who started a community of practice for data science. So we have 200 and 250 people in that community of practice that is distributed across the entire U.S., like regions, states, and the EPA, who comes together on a weekly basis. In fact, we have a weekly meeting today afternoon to talk about some of the things that they are doing at different parts of the organization, enabling and creating that conversation. So to sum up, by the lessons learned will be, by taking that lean approach in building up a data science practice within the organization, I am seeing more and more people getting more comfortable with the idea of doing a data-driven decision making, because we are not saying that give me money and I will show you something in 4 years.
Yeah.
So that's the bigger lesson learned that we have.
Yeah, it's not like he gives us big chunk of money and 3 years from now we'll have something. Chris Steele, what are some of the lessons you learned along the way here as you work these big data programs?
We've learned a lot of lessons, especially in the area of in-memory computing. So if you look at healthcare.gov, I think one of the biggest lessons we all learned from that is that you really have to understand the size and the amount of data coming in and the speed of which it's coming in.
Right.
So in that case, we learned the hard way that we have to do a lot better job of estimating what that data is going to look like, how we're going to be able to handle it, and what are the different technologies out there to address those type of issues. So I think in one regards, I think they were ready for handling the static data. They had the right technology on the back end to be able to house and store that. They just weren't ready for being able to address all of the data and the amount of time that they needed to. So when you think this past enrollment season, they had somewhere in the area of 320,000 concurrent users during peak season, which is a lot for any website.
Sure.
But they were ready for it now because of the lessons learned 2 years ago.
So simulation and things like that before you go live and to make sure you understand what you're getting into before you actually deploy seems to be a good lesson learned. Alan Ford, what do you think there? Alan, what are some of the lessons you're learning along the way as you work through all these big data programs?
Well, I think it's important to talk about open source tools that are available in the big data space.
Open source, big deal. No, open source, open data.
Absolutely. It's very tempting to reach out for some of these open source tools that are flooding the market, almost on a daily basis. Some of them are quite good. And they're also free, which makes it very, very tempting. But it's free like that free puppy your kid brings home and says, "Dad, I promise I'll take care of the puppy."
Yeah.
If you've never had a puppy before, there's a steep and often frustrating learning curve associated with it. So have to be careful. And support's an issue too. Agencies have to know where they can go for support and issue resolution for these tools if they plan to use them, especially if they plan to use them in their critical analytics ecosystems. So I'd want to ensure that agencies choose their vendor partners carefully in these instances and insist on partners with a good track record of supporting some of the more niche tools.
Yeah, good advice there. Let's talk a little bit now about some of the difficult things, some of the challenges out there, some of the hard things, some of the hoops you got to jump through, the constraints that are still out there, things that you need to overcome to get to where you want to go. Let's start with Robin this time. Robin, what are some of the challenges you face day to day that you need to overcome in order to get where you want to go with this?
So I think I will go back to the initial 3 points that I started with, the people, process, or the people, technology, and the finance. So from a people perspective, as you can imagine, if you are in the federal government, everybody is aware of the fact that hiring is not easy. So the question is, how do we build a portfolio of data science and analytics within EPA, where I know that it will take probably 6 months for me to go through the whole process to get a person in. So what we have done there is we are looking at, one is the community of practice acting as a mechanism for creating that collaboration so that we can find people within the organization who has maybe one skill for a data scientist, but they don't have the other one. So we are doing training. We are giving them specific training that will get them up to speed on programming or get them up to speed on statistics or whatever it is. So that's one. From a technology perspective, to Alan's point, I agree on the fact that open source tools are very tempting to use, but I have a different take on that problem. The way we are evolving now is we are looking at some of the enterprise-grade open source tools, and the benefit for us is going back to the third point, which is the budget-wise. I don't need a big money chunk to start the process. Right. But to Alan's point, what we need to be very careful of is just don't go and put that in production before making sure that this is something that can handle, right? So what we are doing is we are taking very cautious steps and making sure that the open source is actually going to serve our needs. And if they cannot serve our needs, then we are starting to identify who is that proper vendor or alliance that we can create that will give us that support to make sure that this can run at the enterprise grade level that we are expecting to do.
Yeah, I mean, there's open source tools that have gone through rigors and due diligence and standardization, things like that. That's one set. And then there's some things that are just flying out, like an app you pull down that hasn't been tested anywhere. I mean, I think there's a big difference between those that have been run through rigorous testing and are now become standards. Zach, what do you think? What are you learning along? What are some of the challenges you're bumping into as you try to make progress in here?
Do I get to use the C word first in this program?
You get to use it. Someone's got to use it. I mean, so throw it out there.
So it's about the culture.
The culture,
right? So
135 straight shows where culture enters the issue with challenges.
Yeah, with all the change we're doing, something has to stay the same, right? Yeah. So this is something that doesn't change, and it's actually change management, which is the challenge here. Mm-hmm. NOAA has been producing data products from the moment we were producing, taking in data. The challenge here and the having to do with culture is that people look at this and they say, well, wait a second, I produce products. The private sector is producing products. What am I supposed to do? And what we're working to do is make sure that people understand that this is not a zero-sum game. Mm-hmm. The National Weather Service actually has gotten that for a long time. We have an entire multi-billion-dollar industry that is built on adding value to the data and products that NOAA generates today. But there are a lot of other folks who've been doing things which are now going to be similar to what industry is doing. And what we've seen from just so far as we've gone is that it isn't a zero-sum game. It's a win-win proposition. Right. The industry gets to come up with products and that are applying the research. And that frees up cycles figuratively in terms of the scientists who now can do basic research on what products we can get from this data, as well as literally. It frees up IT cycles because that's a problem that's moved off too. So the first thing is making sure people get that so that they can embrace it and help accelerate it. There's some other challenges as well. The folks who don't have that issue but are concerned about day-to-day operations want to make sure that in the process of serving up all this data, we are in fact protecting operations and not burdening them by hitting them directly. There's always concern about security. We're still moving things to the cloud,
absolutely,
and you want to make sure that the bad guys don't come backwards in it, which means we need technologies for one-way functions and some of the standard stuff, which gets highlighted when you put all this data out there in a very public way. Another area, so that's those challenges that we've come across in the big data project itself. Then there's the place where we have big data challenges that are associated not with the cloud type of data, but with the big data that we use in our high-performance computing, our models. Right. The challenge there is that as we increase the resolution of those models, we find that the exascale computing systems that we have to use to generate products in hours instead of days, weeks, and months, since these are things that have to be done quickly, may not be, the input-output capabilities may not be able to keep up with that. Right. So that's one technical challenge. Sure. And the other technical challenge is that if we're going to share this and collaborate across the world with these high-resolution models, how do you do that without also giving them exascale computing themselves? Because this isn't the stuff you can just sort of distribute like you can with a cloud. It's a technical challenge that we have to deal with.
All right. Yeah, there's some great stuff there, Zach. We'll have to think through some of those in terms of the scientific mission you're talking about there. But I want to hear from Frank and our other panelists too, but we need to take a short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM. I'm Jim Flyzik here with Zach Goldstein from NOAA, Robin Thottungal from EPA, Frank Konieczny from U.S. Air Force, Chris Steele from Software AG Government Solutions, and Alan Ford from Teradata Corp. We're talking big data. When we went to break, we were talking about challenges. We heard from some of our panelists, but haven't heard from Frank yet. Frank, how about some of the challenges you bump into every day?
Well, the first challenge that we have is that we have lots of data sets across the Air Force, and the question always is who has what data, because we do analysis. We do various analysis based on critical situations. And sometimes you just don't know where the data is.
Right.
And so that's why one of the reasons why we formed the data panel was to help everyone understand where the data is across the Air Force, because simple things like even training data is not located in one place. So if we were correlating, the fuel expenditure analysis we did with the training records, we'd have a difficult time actually finding where the training records were.
Sure.
That's the first challenge. Second challenge we have is the amount of time it takes from the ingestion of the data to the analysis of the data. Some of these cases, we want to do it really quick, and we're talking about petabytes of data rolling in and trying to move that into a data center that could actually do the analysis fast enough for us to get something done. And that's been a problem all along.
Sure.
And you just can't say...
It's easy to see.
Because you can't keep, data has a shelf life, really. And, the question for us is this shelf life in many cases is only even a week old. It gets stale. Mm-hmm. And so the question becomes, how fast can you actually analyze the data? And so we're talking about, doing machine learning and some other information as well to actually get to the point where the analyst really can't look at all the data. Right. We have to have a machine to actually do this. And the last thing, of course, is always security. Yeah. Security, security, security. Tag the data with security controls. Make sure that the data is secure.
Yeah. And we do quite a few shows on cybersecurity during the year because it's such a hot topic.
Yep.
Yeah. Alan Ford, what's challenges you bump into as you work through these programs?
Well, I'm glad Zach brought up the culture word, because big data requires a cultural change in the form of an agile approach to development and implementation. And some agencies are just tied to a more traditional IT development methodology.
That's pervasive all across government and industry.
Yeah, absolutely. People must be free to experiment and innovate with big data, to fail quickly but also smartly and intelligently so they can move on to the next data experiment quickly. And they have to be able to do it without a 100-page requirements document needing 6 levels of approval before they can get started. So if an agency wishes to generate new insights by way of its big data, it can't be afraid to foster disruption and drive innovation to make these changes happen. Self-service is an example of a disruptive process. Data scientists should be allowed to access raw data in a data lake so they can quickly acquire the data they need without having to submit a request to a data integration team, which may take days or weeks to satisfy. You don't want to impede or slow down big data investigations with outdated procedures.
Yeah, well said. Good point. That culture issue comes up. I think it was Robert Kennedy that said 1/3 of everybody's against everything all the time, no matter what it is. Chris Steele, what do you have to add to the conversation around challenges you face?
So I think I'd combine both what Frank and Alan said, in that right now we're at a point on the learning curve where we really don't have great understanding of a lot of these different patterns and reference architectures that really define what the technologies are for the different problem spaces. So I think that is naturally just part of a learning curve where I think we'll get there. And as we do so, that tends to resolve a lot of the cultural issues. So if you look at one of the examples, like how do we deal with moving all of this data in at the speed we need to? We need to be able to understand that problem space is more streaming analytics. We need to be able to stream it in. We can't put it into a data warehouse and then run batch analytics on it. We need to do that in real time. We also need in-memory processing. We need to be able to store all of this data in memory so we can run the analysis at the speed that they need to run to. Mm-hmm. So once we get these reference architectures and we have these different patterns out there, again, I think that will tend to solve a lot of the cultural problems that we're looking at now.
Yeah, decision-making in a world where decisions need to be made as time approaches zero. That's where we are in today's world. That's your shelf life issue and so forth. We're at the part of the show where we like to turn and talk about the future. Where's this all going? What's the world going to look like down the road? And I want to hear from all of our panelists. You all have about a minute and a half or so to put on look into your crystal ball and tell us what the world's going to look like down the road as a result of these programs. How will big data make a difference in the world we live in? Let's start with Alan Ford at Teradata Corp. Alan, what's it look like to you down the road? How are these programs going to change the world?
Well, we at Teradata like to talk about the sentient enterprise, and we don't have enough time to discuss all the characteristics of the sentient enterprise or organization, but we can talk about one of the end results. and that's the development of autonomous decisioning platforms. Big data is going to continue to grow at an ever-increasing rate, and for the most part, so will the platforms that host these data. What doesn't scale easily is people. More data, more reports, more analytics, and more information require more eyeballs than we have to absorb and act on the information that's presented to us. So agencies will need to create autonomous decisioning platforms at scale that are analogous to the self-driving car or the automated high-speed or high-frequency trading platforms of today. These systems can allocate the grunt work of interpreting results to algorithms and delegate the strategic thinking to people. In short, the Ascension Enterprise is the algorithmically run organization, and we need smarter machines and systems, and that's where big data is going to take us.
Wow, does that mean I'm going to be doing the show and there's going to be like robots around the table that are all using algorithms to talk to me? And interesting, though, very interesting. Robin Thottungal from EPA. What's it look like to you? What's your crystal ball look like? Where's this going? What's the world going to be? How's the world going to be different because of these big data programs?
So I have 90 minutes to say what this is going to look like. Okay.
Well, you can take 90 minutes, but we're not going to be here.
Oh, sorry, 90 seconds. Sorry, my bad. So I think one thing I always bring back to is the mission that we are working on, protecting the American health and the environment, right? And our CIO, Ann Duncan, usually says that the pollution does not stop at the boundaries, which means what we are doing at EPA is going to touch the life of everybody on the planet. And NOAA is the same case. Now, when I think about this problem, I think one of the things at least I'm trying to think about from the perspective of creating an ecosystem. And what I want to do is, or what I see EPA leading is, creating an ecosystem for environment-related analytics and data set. And I see this living in the cloud computing world because recently I was presenting at the Strata conference in California and talking to different data scientists and the companies like Uber, companies like Databricks, companies like Google, Facebook. And one of the things that I see is there is a tremendous amount of excitement around the use of open data or the data from the government for creating products that can help the American public or people to make the right decisions. For example, wouldn't it be great if you have an app that shows what is the air quality of this neighborhood that I'm standing? So with that in mind, one of the things that we have started doing is publishing our large volume data set onto the cloud computing platform. And we had a agreement with Amazon recently where we published a 3 terabyte data set that shows the air quality of US from 1988 to 2015. And that's not a data set that we have collected. It's a result of a simulation. So what we see happening is in future, we will have these analytical platform that will exist in the cloud that will create an ecosystem for people to use that data set to create products. And at the same time, I see this as a ecosystem that is not going to be EPA alone. I want NOAA to be a part of it. I want USDA to be a part of it. I want everybody within the federal government who is using some kind of an environment-related data set to be a part of that platform so we can create that successful collaboration to create products for the agency or for the government and for the American public and also for enabling the economic growth of companies. Excellent. And finally, what we are doing in this direction is Jeff Chen, he is the Chief Data Scientist for the Department of Commerce. So I'm having conversation with him to identify what can we do from a collaborative project to show the value of sharing data from the commerce, which includes NOAA, which includes NASA, which includes census. Now working with NIH to see how we can bring in healthcare data set. Phil Bonney is the Chief Director for Data Science in NIS, similar with CDC, similar with FDA. So it's not a future I'm talking about, but we are already moving towards that direction. So I want to see this happening on a faster time frame.
Working to create a better world.
Exactly.
Chris Steele, what's the future look like to you?
I think Alan already nailed it on the head. I think that where we're moving to is as the percentage of data continues to grow exponentially, the amount of data, that the percentage of that data that we can actually store and use for later analysis is going to continue to shrink just due to sheer size. So what we're going to start moving towards is more of the streaming analytics, the machine learning algorithms where we're just constantly digesting the new data as it comes in, and we're not really storing it. We're not going to have raw data anymore. What we're going to have is we're going to have that distilled knowledge that came out of that data, much like people think. So we don't memorize books, we read them. And
that'll enable you to predict things that are going to happen before they happen.
Exactly.
Things like that. Frank, what's it look like to you? What's the world going to look like down the road?
Similar theme, but we think you're going to get enough machine learning and deep learning of the data to actually start doing predictive analysis and looking at various alternatives. Because we want to be able to say, okay, even with Robin's pollution environment, what is going to happen in the next 20 years in that pollution area, given some of these factors, and you can use open source data to that, or you can determine what events are going to, you predetermine what events should occur to actually lower the pollution levels. It's things like that we want to be able to do in terms of defense and everything else. Is when we do an event where we get the data coming in, streaming in, we want to be able to say, okay, this is what the data tells us. This is what we predict is going to occur next. What can we now do to change that prediction?
Sure.
And that's where we're trying to get to enough deep learning of the data.
So I'm hearing there's a lot of machine learning and predictive analysis is where a lot of these things are going, and that's how the data will be used. Zach Goldstein over NOAA, what's the world look like to you down the road because of these programs? How is it going to change what we do and how we live and things that go on at NOAA as a result of big data programs being implemented?
So there are a number of ways.
Okay.
I'll start with the more obscure and end with the more important.
Okay.
So one of the things that's obscure, actually, and important, they're all important, is the goal of the National Strategic Computing Initiative, which is to tie high performance computing and data analytics. So one of the things that I see looking ahead is that we're going to be able to make government data available with high-performance computing for not only government uses, but the general public's uses, and that's going to require tools for access that don't exist today. So one of the key tools that we're going to be needing is the ability to do queries by natural language. A lot of the artificial intelligence advances that have been discussed here with machine learning will be the technology that makes that necessary. But that human interface, the ability to not have to figure out, not have to know anything about how the data is structured or where it is or what the relationships are, but to have the smarts be in the computer itself to understand, because it has done machine learning on how humans communicate, that new interface will be key to achieving the vision of that strategic computing initiative to leverage the power of high-performance computing with big data and data analytics. Another thing is happening, the Internet of Things. I haven't heard that buzzword mentioned in this program yet.
We did a show on it just not long ago, and it went over big.
But the Internet of Things is a big generator of big data. As I said earlier, in NOAA anyway, everything we do begins with an observation. And how amazing would it be if instead of just having the networks that we have now for temperature gauges and rain and pressure, if the world were instrumented by the smartphones we carry? Scientists have already shown and documented the accuracy and resolution of the pressure sensors that sit in smartphones and tablets and how they mapped to the pressure changes that occurred when Hurricane Sandy hit the New York metropolitan area. Right? So imagine that big data. There may actually be more, I don't know the math, but there may be more mobile devices than there are people in our country.
I would think so.
And if you
I think my kids all have about 4.
Right. And you could just tap into that. If you could tap into that as a source of observation, imagine the resolutions, imagine what we can do for our forecasting ability and our science. When we think big data in NOAA, we typically think about it in terms of, well, I've got this model, I need to feed this model, and if I can get this additional data from this satellite, then I can feed the model, I can improve the resolution. And so it's a very deterministic thought process. Right. It's true that models are technically statistical experiments, but there's a lot of determinism. So what we want to do is use the big data that we have in data analytics to not just improve our models, but look into the data and find out what questions aren't we asking. What can the data tell us about what questions we should be asking? Right. And that's something where we need to be doing a lot more.
Excellent.
And the last two things I want to mention are economic growth. We've already talked about that. And the use of new services to improve services at the local level, at the commercial level, and finally, improving our mission itself.
Right. That's what it should be all about for everybody, right?
Right. I mean, and right now, if we can give you an extra 3 minutes, an extra 20 minutes for tornado warning, That saves lives.
Absolutely.
Big data can do that.
Absolutely. Well said. And I think that's what it's all about, improving mission, saving lives. Heard a lot of good stuff today. But what in the progress area, I heard these processes are massive and that greater use of the cloud is going to be helping. I heard a lot about water monitoring and purification programs that over EPA and how you're using big data to do that. We talked about social sites and how big data can address some of the social sites and produce information. On specific programs, we heard about how Air Force has some fuel usage big data programs. We heard about sharing data to identify bad actors and who's out there and so forth. We heard about all the Doppler being transferred to the partners and what a big difference that makes in NOAA and how it frees up cycles there. We heard about Air Force fleet management and how big data is being used to manage there. Lessons learned, some of the things that I resonated with me, that you have to understand the main objective, the use of the data before you actually get into doing it. You have to understand the possibilities and what can be done. Lean startups to get you rolling so you can prove concepts to get some buy-in and deal with that. And you need to look at simulations to manage impacts, to know what you're getting into before you go actually deploy. When we talk challenges, we talked about people, process, finance, obviously budget, and people, we talked about depth. And I think every agency suffers from that. You just don't have deep benches. You know, it's not easy to get the people. It's not easy to get the skill sets, the STEM programs, and so forth. And of course, our favorite, the culture change. Every show we do, when we talk challenges, we talk culture and how people are set on doing things. And these programs are pushing them different directions. And we talked a little bit about understanding, creating an understanding of what you're trying to do across the organization. On the vision stuff, I heard about autonomous decision platforms. I heard about machine learning, high-performance computing, and data analytics. But basically, it all comes down to me is creating a better world for ourselves and generations to come. I want to thank our panelists for taking time from their very, very busy schedules to being with us today. I want to thank our sponsors, without which we don't have a show. I want to thank the good people here at Federal News Radio for everything they do to make this a fun thing to do. And most importantly, I want to thank our listening audience who tune in each month to hear the program and listen to us. You've been listening to the Federal Executive Forum on Federal News Radio, 1500 AM.